I'm about to start on another element here, but I wanted to do the side view of this piece. But before I do it, I wanted to talk about something else. I'm going to just put this aside for a moment. I want to talk about this. These are computer printouts. This is a computer printout of all the different sizes, from the rounds, the squares, the ovals, pear shapes, and I happen to use the pear shape here. And I was using the 15 by 10. That's how I derive getting the right stone size, because these are accurate stone sizes. When you're doing this, there's very few that generally give a side view. Like here, you have a side view of the square, and the ratio generally is the size, like in a pear shape. Let me go to the round first. If I go to a round and it's a 10 millimeter, 10 would be multiplied by 0.06. That would give you the depth of the stone. So it would be like 6 millimeters deep, 10 millimeters wide. You go to a pear, you add the two numbers together, the 9 and the 13, divided by 2, and that number that you get, then you multiply by 0.06, gives you the depth of the stone on an average. That's the average depth. Stones can be cut thinner. You see it here as an example. Here's one that shows the side view. You can see the ratio in relationship to the length of the stone. The marquee, the same way here. They've done it in a few places. Here in the oval, you see it again in the oval here. So this is very handy to see and to learn, the 5 by 7, and this is the depth of the 5 by 7 on an average. That gives you the best refractive light through the stone. But there are certain stones that are very dark. It doesn't really matter about the depth, and it could be done shallow or it could be done deeper. Shallow is better because if it's going to be a ring, it'd be too high if the stone is cut too deep. So this is the ratio. So I just wanted to mention that quickly. I'm going to go back to doing the side view here, and I've been working on this part here and trying to get, and what I do is I line everything up. If you notice these lines that go to the top, these all are parallel to the distances that are measured on the top view here. So as you do the side view, all of this has to match up with everything. Like here I have the prong. I didn't have enough room on this other paper. I was going to put it on the other paper, but I had to go to another piece of paper and use an overlay. So I'm going to do that. Bringing this line down here, if I put this line here and I use the line that I drew here to make it parallel, so I make the distance from here to here, here to here is the same. I can draw a line down like this, and that gives me where that line ends on the side of the shank with a side view. So that's where we're at right now.